These are the Chapter 3, Note 6 on residuals. Today we'll talk about what residuals are, and we'll also graph something called a residual plot. We're going to start off with this list of data that's shown at the right here. We have values for x and y. And there's two steps I'd like you to complete. The first step is using your calculator to find the least squares regression line equation that fits the data. You're going to enter in these 3 points into list 1 and list 2 in your calculator. So you're just going to go to Stat Edit. You're going to put those points in list 1 and list 2. Come up with the equation for the least squares regression line for step 1. And then step 2, I want you to plot the 3 points that are listed and the least squares regression line equation on the coordinate plane that's shown below the table. That's this graph that's kind of down here. One thing that you can do to get nice coordinates for the least squares regression line is when you type in your equation in your calculator, go to second graph and you can get a list of points. That'll make it a little bit easier to graph the line. I'm going to have you pause the video. When you get done with steps 1 and 2, you can restart it, and we'll come back to step 3 in just a moment. So we have our equations. Y hat equals 2 plus 2.5x. Don't forget the little hat above the y right here. We have our graph of our points, 1, 5, 2, 6, and 3, 10. And we have the line that goes through these points pretty well. Again, I'm using the table that you see on the calculator screen here. I plotted some points and used those to help me graph this line. We're on to step 3. It says calculate y hat for each x value in the chart. Write these y hat values in the chart. You can see based on our table here that when we plug in 1 for x, obviously 2 plus 2.5 times 1 is equal to 4.5. And just using the table feature on your calculator, you can find the values when x equals 2 and when x is equal to 3. We're moving into step 3, which says calculate the residual for each value in the chart and write the sum of these residuals in the space under the chart. So I'm going to have you do real briefly is calculate the residuals. The residuals are basically the vertical distances each of our points in bold here are from the line. You can find it by taking the observed points and subtracting it from its predicted value on the line. In other words, we're just taking y minus y hat. For example, here if you take 5 minus 4.5, you get 0.5. And if you take 6 minus 7, you get negative 1. We'll calculate the other value. What these values represent on the graph are the vertical distances each of these points are from the line. So if we're talking about the distance from our point 1, 5 to the value on the line right below it, 4.5, that distance right here is equal to 0.5. If we're talking about the distance this point is from this line, that distance is negative 1. What I'd like you to do is find out this other residual value, calculate the sum of these residuals, and then we'll pick up in just a minute. Alright, so we've calculated our other residual. It's equal to 0.5. When you take the sum of your residuals, you should always get 0. So if you're doing the problem correctly, you should always get 0 for this residual. I've written a little 0.5 right here to denote the distance vertically from this point straight down to the line. Now as we progress into number 4, if the original point is above the line, which you'll notice it is with this third point and with this first point, points above the line have positive residuals. Points below the line, like our point at 2, 6, is below the line. Points below the line have negative residuals. And as stated earlier, the sum of your residuals is always equal to 0 if you've done the problem correctly. Your graphing calculator is kind of nice in the fact that it can actually calculate these residuals that we found in this table up here automatically. I'm going to show you a way that you can do this. We're going to follow the steps down here at the bottom. We're first going to enter our points in list 1 and list 2. I imagine if you go to Stat and enter, your points are probably already listed there. We're going to find the least squares regression line equation next. To do this, we go to Stat Calc. Remember, in this class, we use option number 8. We're going to use just list 1 and list 2. So if you have a newer calculator, make sure X list is list 1, your Y list is list 2, and you should generate our equation again. We're going to go back to your list, and the third bullet, we're going to highlight L3. So go to where L3 is, actually highlight L3. Make sure you're not in the little space below, but you're actually highlighting L3. If you hit enter here, you can choose an option which is called Resid, which is under the list menu. The list menu is under second stat. And if you go to second stat, underneath names, you may have a whole bunch of lists that are named here. One of your lists should say RESID for residuals. And what's kind of cool is you can hit enter a couple times, and your calculator actually generates the same numbers, 0.5, negative 1, and positive 0.5 that we had in the chart at the top of our paper. Continuing on, in our next problem, we're going to look at a list of data that shows the height of a plant in inches after several months. What I'm going to have you do in just a moment is you're going to enter your months in list 1 and your heights in list 2. We're going to follow step 6, which is copy what the scatter plot of these points look like from your calculator. And then you're going to do step 7, which is find the equation of the least squares regression line and values for r and r squared. You can round those values to the hundredths place. We're going to take care of step 6 and 7. Pause the video and we'll see what you get in just a moment. So on your calculator, the equation you get for your LSRL is y equals negative 8.3 repeating plus 7x. We said you can round to the hundredths place. Don't forget, although your calculator doesn't show it, you do want to put the hat above the y for your least squares regression line. You do calculate an r value of 0.98 approximately. R squared is 0.96. When you take a look at the graph of this function, it looks something like this picture right here. Now, if you actually graph our line on top of our graph, what you'll notice is that the line does a good job of going through the points. It kind of ensures that the r and r squared values we came up with are accurate. When you're interpreting what r and r squared stand for, recall that the definition of correlation, or r measures the strength and direction of the linear relationship between two quantitative variables. So when we're interpreting r, we want to talk about the strength. R is 0.98. That's a very strong relationship. Our points have a positive trend. R is a positive number, so we have a strong positive, always linear relationship. When you're talking about what R is, what correlation is, it's a linear relationship. And it's between two quantitative variables. In this case, our variables are height of the plant and month. So when you interpret what R is, you need to talk about the strength and direction of a linear relationship between your two quantitative variables. When you're talking about r squared, recall that our definition for r squared, or a coefficient of determination, is the fraction of the variation in the values of y that is explained by the least squares regression. R squared here is 0.96. This can be written as a percentage. So we're going to say that. This is your percent, 96% of the variation in the values of, in this problem, our y variable was height, is explained by the least squares regression. Notice that I've left off the word that, which is part of our formal definition here. It doesn't read very properly if you include the word that when you talk about context, because then it would say 96% of the variation in the values of height that is explained by the least squares regression. It just sounds better, I think, without that term here. So now you can say, what is r squared in this problem? It means 96% of the variation in the values of height is explained by the least squares regression. I think that sounds a little bit more clear. As we move into step 9, I'm going to ask you to use your calculator to calculate the residuals, and we're going to put the residuals in list 3. We're going to follow the same steps that we did on the other side of the worksheet. So we're going to first start by going back to our calculator. We're going to ensure that we have our points in list 1 and list 2. We're going to do our lin-reg step again. So stat calc lin-reg number 8. This will generate our least squares regression line equation. You need to always tell your calculator what line you're working with in order for the calculator to properly calculate the residuals. Once you have the lin-reg step, we're going to go back to your calculator, stat edit. I'm going to go up to list 3, hit enter, and we do second stat. And you'll notice there's your residual list, number 7. We hit enter, there's a list of residuals. Now what we're going to do in this problem is a little different than what we did last time. We're going to make something that's called a residual plot. Now to sketch a residual plot, what we do is we graph the months in list 1 with the residuals in list 3. So when you go to second y equals, we're still going to use our stat plot with our scatter plot, but this time my y list is going to be my list 3 data, my residuals. I'm going to go to zoom 9, and what we have here is our residual graph. Now we don't need this line that goes through here anymore. I'm just going to get this out of here. So this is what's called a residual plot. We'll make a picture of this on our sketch right now. Now what exactly does the scatter plot show? Well, if we go back to our original graph that we showed at the top of our paper here, you're going to see essentially the same relationship along this slanted line here, you're going to notice that there's a point above the line at the beginning and another point above the line at the end, and then the rest of these points kind of dip below. This is the same relationship that you see here, except that we've more or less made this diagonal line go horizontally. And the residuals are the vertical distances that each of these points are from the line. So for example, this point right here that's below the line, if we were to measure that distance straight up here, that corresponds with the distance on our calculator from here to here. This graph at the right for number 10 is called a residual plot. If I ask if the residual plot shows a curve pattern or a random scatter of points, to me there's definitely a curve pattern here. And typically what this illustrates is a curve pattern illustrates the fact that the original data is not best described as linear. So despite the fact that a line fits through these points nicely, there's probably a better fit for the data, maybe a parabola or something like that. If the residual plot actually shows a random scatter of points, then the original data can be best described as linear. That should be enough to help you get started on your homework for today. So today what we've learned about are residuals and how to make a residual plot.